In this video, we're going over an overview of transformational geometry and then specifically looking at translations. We'll be working on pages 7 through 9 in our Algebra Summer Math Work Packet. Transformational geometry should be familiar from 6th grade. That's when we're shifting, flipping, rotating geometric figures or points within the coordinate plane. Okay? So we have a few different transformations we're going to look at in this work. We've got reflections, right? A flip, rotations, turning, translations, a slide or a shift, and dilations, which is an enlargement or a shrinking of a figure. Some important vocabulary words in addition to that is pre-image, being the original figure, and image, being the figure after a transformation happens. Okay? A transformation is an operation that maps an original figure called the pre-image onto a new figure called the image. If we look on the graph to the right, triangle ABC is our pre-image. Okay, and we name that triangle, that means triangle, and we name by the vertices ABC. The pre-image in naming and on a graph never has marks around it, it's just ABC. It's the image that has those little, almost like apostrophe marks next to the letters of the vertices. And when we read that, we call that triangle A prime, B prime, C prime. So we read those apostrophes in math as prime. That just means the next one after the original. We'll see multiple transformations, and the second of those transformations will have two apostrophes or two prime marks, and that'll help us keep track of it. A transformation can change the location, meaning the physical position, the orientation, right, so sort of how a shape's rotated, or the size of a figure. Then there's a special vocabulary word called an isometry or a rigid motion. That's a special group of transformations that preserve the size and the shape of a figure. So let's just jot that down. A transformation that preserves, or you could say doesn't change, the size and shape. And by shape, we mean, the triangle looks the same before and after its transformation. So with that, we're saying that if something's in isometry or a rigid motion, that all corresponding angles and sides, and corresponding just means those matching sides and angles that have the same position, are congruent, right? And we should be familiar with that word congruent, the geometry word meaning equal or same. Translations, reflections, and rotations are all isometries, which means the only one that is not an isometry is the dilation, or a rigid motion is the other vocabulary. Okay. Now we're going to specifically look at our translations, which really a translation is a sliding or a shifting of a point or a figure. So translations are to vertically and or horizontally shift, or we could say slide, a figure or a point in the coordinate plane. And there's a few different notations we use to show that. One is coordinate notation, where we say we take our original coordinate, x, y, and then we shift it, right? So that means we're either going to add or subtract to the x coordinate, which we show x plus h, and add or subtract to the y coordinate, we show y plus k. So h represents our horizontal shift, right? Because the x's go left, right, where a positive would be moving to the right, a negative would be moving to the left. and K represents our vertical shift, where a positive would be moving up and a negative would be moving down. Transformation notation, that's where we use the big T, right? The big T tells me that it's a translation, and we saw that notation in our definitions page before. And then we just use H and K to describe how it's translated. Sometimes you'll see that with parentheses around it. Other times you'll just see it like that. Either one's fine. So let's give one a try. So on the graph, we have labeled a quadrilateral, QRST. Okay, that's our pre-image, our starter. We're given the vertices here. We're also can see them on the graph, and we're asked to perform a translation. XY goes to X plus 5, Y plus 7. So if I look at that, I'm adding 5 to the X coordinate. That means each point's going to go right 5, right? And adding 7 to the Y, up 7. And there's a few different ways we can work with our translation on the coordinate plane. One is to just go from your original and kind of tap out with your pencil right 5 and up 7. So if I do that with Q, I'm going to go to the right 5, 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5, 6, 7. And I put my point there, and I know that's going to be called Q prime because now it's the image point, and that's the ordered pair, -1, 5. The other way to do this is to use your coordinates. So if I look at R, -3, 1, if I add 5 to the X value, that's going to give me a +2, meaning that R prime is going to be located at an X coordinate of 2. And then I'm going to add 7 to the Y value, which will make it 8, the ordered pair 2, 8. So then I can find it, 2, 8, and graph. And then label that R prime, right? So try either method, both methods, as you find the location of S prime and T prime. Okay? So S, if I count it out, I'd go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. There's S prime, which now has an ordered pair of 6, 2. Okay? And then T, if I try just adding to my coordinates, -2 plus 5 would be a +3. -7 plus 7 would be 0, meaning it's going to be on the x-axis at 3, 0. T prime. So whichever method you prefer, whichever method works for you, right? Hopefully you're using a straight edge here. I can't really use a straight edge on the computer. But now we see our image, Q prime, R prime, S prime, T prime. We can see that they're congruent. They have the same shape, showing us it's an isometry. Okay. Example 2 doesn't give us a coordinate plane. It just gives us a couple of points. So we're asked to describe the transformation below in words and then identify the image and pre-image points below. And it's given to us in transformation notation. So it's a translation, -3 in the x's, +4 in the y's. So negative in the x's is going to be left. So we're going to say left 3. And then a positive in the y's, up 4. Right, and we're just kind of following the order. X's come first, so we'll talk left, right before we talk up, down. Now we're given a pre-image, A, and asked to find the image. So the pre-image is -4, 7. So I'm just going to kind of add. -4 plus -3 would be -7. +7 plus 4, +11. So our image point, A prime, would be at -7, 11. The next one's a little tricky because this time we're given the image and we're asked to figure out the pre-image. So really here we have to work backwards, right? So what's the reverse? The reverse of left 3, up 4 would be right 3, down 4, right? So that would be our reverse directions. So using our reverse directions, I would be adding 3 to 8, which would give us 11. Subtracting 4 from 2, which would give me -2, right? And if I look back from pre-image to image, subtract 3, yep, that works. Add 4, yep, that works. We're good. Okay? The last type of translation problem we could be asked is to describe a translation that's already been given to us. So describe the translation that maps the preimage to its image in coordinate notation and in transformation notation. Okay? So first thing I want to notice is that triangle DEF, that's our preimage. Right? Where this is our image. And then I'm just going to pick one point to work with, D, E, or F. I'm going to use D. And I want to see either from coordinates, right? I can see D is the ordered pair -4, 5, and D prime is 3, 9, how it traveled, or just counting it out that I can see it went to the right 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3, 4. Right, so that would tell me we went right 7, up 4. And if I look, -4 plus 7 gives us 3, 5 plus 4 gives us 9. So I described in words. Now we're going to use coordinate notation. So coordinate notation, that's where I would be saying xy goes to x plus 7 because it's to the right, y plus 4 because it's up. In transformation notation, that's where we'd be doing that t, +7, +4. Okay. And that's it for translations.